Hello and welcome to my channel, Boo Snakes and More. Today we'll be talking about melting ice that's slowing the rotation of the earth, so please like this video and subscribe to the channel. And for more videos like this, also watch my other house channel, A&A Snakes and Stuff, my youngest son's channel, Henny's Toys and Games, or my oldest son's channel, Lord Chris 10. Now let's dive into the video. Climate change is altering the earth to its lateral core. Literal core, new research suggests, as polar and glacier ice melts because of global warming. Water that was once concentrated at the top and the bottom of the globe is getting redistributed toward the equator. The extra mass around Earth's middle slows its rotation, which in turn has a lengthening effect on our days. A new study offers more evidence of that dynamic and further suggests that changes to the planet's ice have been profound enough to affect the Earth's axis, the invisible line at its center around which it rotates together. Those shifts are causing feedback beneath the surface, affecting the fluids that move around in Earth's molten core. The findings were published in two journals, National Geoscience and Proceedings of the National Academy of Sciences over the last week. The studies, along with similar research published in March, suggest that humans have tinkered with foundational elements of the planet's physical properties, a process that will continue until some time after global temperatures stabilize and the melting of ice sheets reaches an equilibrium. You can add Earth's rotation to this list of things humans have completely affected, said an author of the two new studies. Bendikit Sanya, an assistant professor of space geodesy at ETH Zurich in Switzerland. The altercation to Earth's spin is significant enough that it could one day reveal the influence of tidal forces caused by the moon. Sergio said, if carbon emissions continue at extreme levels, in general the speed of Earth's spin depends on the shape of the planet and where its mass is distributed, factors governed by several contracting forces. Scientists often offer a comparison to a figure skaters whirling on ice. When skaters spin with their arms outstretched, the rotation will be slower. But if skaters' arms are kept in tight, they spin faster. Somewhat similarly, the friction of ocean tides from the moon's gravitational pull slows the Earth's rotation. Historically, that has had the largest influence on the planet's rate of spin, Sojona said. Meanwhile, the slow rebound of the Earth's crust in some high-latitude regions after the removal of Ice Age glaciers works in the opposite direction, speeding up the planet's spin. Both of these processes have long been predictable influences on the Earth's angular velocity. But now, rapid ice melt due to global warming is becoming a powerful new force. If humans continue to pollute the planet with carbon emissions, Sundrum said, the influence of ice loss could overtake the moon's effect. In the worst scenarios, then climate change would become the most dominant factor, he said. An important fourth factor influencing Earth's spin is the motion of fluid within its core. Scientists have long understood that can accelerate or slow the planet's rotation. a trend that can shift over 10 to 20-year intervals. Right now, the core is temporarily causing the Earth's spin to speed up slightly, contracting to slowing due to climate change. Climate change appears to be affecting Earth's core, as well as a result of melting ice and shifts in the planet's rotational axis. The researchers behind the new study built a 120-year model of polar motion and how the axis shifts over time. They found that changes in the distribution of mass on the planet due to melting ice likely contributed to small fluctuations in polar motion. Sojourner estimated that climate change was most likely responsible for 1 meter of change over 10 years. The research further suggests that the movement of molten rock inside the Earth adjusts to the changes in its axis and rate of spin, a feedback process in which Earth's surface influences its interior. The rotation changes slightly, and that we believe can indirectly have an effect on the core, Sojourner said. This is something which is not very easy, or not possible to measure directly because we cannot go down there. The findings have implications for how humans keep time and for how we position satellites in space. If you want to fly a new mission to Mars, for example, we really need to know how the state of the Earth is exactly in space. And if that changes, we might actually make a navigation error or a mistake, Sojourner said. A 1 meter change to Earth's axis, for example, could mean a spacecraft misses its target by 100 or 1,000 meters when it reaches Mars. As the timekeeping research published in March suggested that climate change has delayed the need to add a negative leap second to coordinated universal time to keep the world's clocks in line with Earth's rotation. Duncan Agu, a geopsychologist at the Scripps Institution for Oceanography at the University of California, San Diego, who led that earlier study, said the new research meshes very well with his work. It extends the research further into the future and looks at more than one climate scenario, Agnew said, adding that although Sojourner and his co-authors took a different approach, they reached a result similar to his. Multiple discoveries are almost a rule in science. This is yet another case, Agnew said. Thomas Herrig, a professor of geophysics at the Massachusetts Institute of Technology, who is not involved in either study, said the new research may indeed offer insight into how changes on Earth's surface can influence what's going on inside. For the feedback between surface processes and the core, I find that possible, Herring said in an email explaining that large-scale processes at the surface can penetrate to the fluid core. Thank you for watching this video and peace out to the next one.